Hello, and welcome to tonight's Space Sleep Story. If you appreciate what we do here, please like or subscribe for future relaxing nighttime space journeys. Tonight, we embark on a comprehensive exploration of Mars, the red planet. We'll discover towering volcanoes higher than Everest, canyons that would span continents, ancient rivers carved billions of years ago, and robots exploring another world on humanity's behalf. So settle into your most comfortable position, close your eyes, and prepare to know Mars intimately. Before we begin, let us prepare your body and mind with gentle breathing. Take a slow, deep breath with me now. Inhale gently for 4 counts. Hold the peace. Exhale for 6 counts, releasing all tension. Feel your body releasing into stillness, your muscles softening, your mind quieting. Each breath brings you closer to rest. Let relaxation flow through you like a gentle tide. Another gentle breath as we continue our preparation. This time, notice how your chest rises and falls naturally, effortlessly. Your breathing finds its own peaceful rhythm. Hold this peaceful moment, feeling completely safe and supported. Feel the stress of the day leaving your body with each exhale. With each breath, you release a little more into deep relaxation, letting go completely. Tonight belongs to rest and wonder. Look up at the night sky on any clear evening. Among the points of light, one stands out with distinctive orange-red glow, not the brilliant white of Venus or the cream steadiness of Jupiter, but rusty red color, unmistakable once recognized. This is Mars, 4th planet from the Sun, named by Romans for their god of war. That blood-red color captivated every civilization that watched the sky. Ancient Egyptians called it Horus the Red. Babylonians named it Nergal. Greeks called it Ares. For millennia, Mars has wandered among the stars. Mars orbits the Sun at average distance of 1.52 astronomical units, 227.9 million kilometers from our star. About 50% farther from the Sun than Earth, receiving less sunlight, colder, more distant. Yet Mars is our neighbor in the vast cosmos, closer than any planet except Venus during certain months. Distance from Earth varies dramatically as both worlds orbit. At closest approach every 15 to 17 years, Mars lies just 54.6 million kilometers away. At farthest, 401 million kilometers separate us. Mars is roughly half Earth's size by diameter, 6,779 kilometers, compared to Earth's 12,742. 53% of Earth's diameter makes Mars substantially smaller world. Mass equals 6.39 times 10 to the 23rd kilograms, just 11% of Earth's mass. Volume, only 16.3% of Earth's. Standing on Mars, you'd weigh 38% of your Earth weight. person weighing 100 kilograms on Earth would weigh 38 kilograms there, making jumping easier, falling gentler. The Martian day feels remarkably familiar. One sol, as Martian day is called, lasts 24 hours, 39 minutes, 35 seconds, nearly identical to Earth's 24-hour day. Of all planets in our solar system, Mars is most Earth-like for day and night cycle timing. Sunrise, noon, sunset, midnight follow familiar rhythm, just slightly stretched. This similarity makes Mars feel accessible, knowable. Axial tilt of 25.2 degrees compares to Earth's 23.4 degrees, creating seasons similar to ours. Mars has spring, summer, autumn, winter. But Martian year lasts far longer than ours. 687 Earth days to complete one orbit around the Sun. 1.88 Earth years. Seasons last roughly twice as long as Earth's seasons, winter stretching endlessly, summer lingering peacefully. Northern spring lasts 194 sols, while southern spring lasts only 142 sols, due to Mars's elliptical orbit. Orbital eccentricity, 0.0934, means Mars's distance from Sun varies by 20% over its year. This creates pronounced seasonal variations in sunlight and temperature. That distinctive red color comes from iron oxide coating the surface. Rust, essentially, the same chemical compound that forms when iron corrodes on Earth. Mars is rusty planet, ancient iron minerals oxidized over billions of years. Surface composition includes iron-rich basaltic rock of volcanic origin, overlaid by fine dust particles, giving everything that reddish-orange hue. Wind redistributes dust across entire planet, painting rocks and valleys uniformly red. From orbit, Mars glows rusty orange with white polar ice caps, thin blue atmospheric haze barely visible at the horizon. Beautiful, alien, yet strangely familiar world. Atmosphere on Mars is extremely thin. Average surface pressure 600 pascals, just 0.6% of Earth's sea level pressure of 101,325 pascals, roughly equivalent to pressure at 35 kilometers altitude above Earth. Far too thin to breathe, providing minimal radiation protection, yet thick enough to support dust storms, wispy clouds, seasonal wind patterns. Composition: 95.32% carbon dioxide, 2.7% nitrogen, 1.6% argon, only 0.13% oxygen. Completely unlike Earth's nitrogen-oxygen mixture, Mars breathes carbon dioxide. Temperature on Mars varies dramatically. Average temperature, -63 degrees Celsius, far colder than any place humans naturally inhabit on Earth. But extremes span even wider. At winter poles, temperatures plummet to -140 degrees Celsius, cold enough to freeze carbon dioxide into dry ice. At equator during summer day, temperatures can reach +20 degrees Celsius, briefly comfortable. A 300-degree swing from coldest to warmest. Thin atmosphere retains little heat, allowing rapid temperature changes between day and night, summer and winter. Mars is a world of extremes. During Martian winter, the atmosphere itself partially freezes. Temperatures drop low enough, -125 degrees Celsius, that 25 to 30% of entire atmosphere condenses as dry ice at polar caps. Carbon dioxide snow falls, accumulating meters deep. Then during spring, that frozen carbon dioxide sublimes directly back to gas, returning to atmosphere, creating seasonal pressure variations across entire planet. This cycle drives powerful winds. Mars breathes with its seasons, atmosphere expanding and contracting annually. Imagine a world where significant fraction of air freezes out every winter, then returns every spring. Alien physics, alien beauty. Water exists on Mars, but locked as ice. Substantial water ice fills the northern polar cap, covered by seasonal carbon dioxide ice during winter, revealed during summer. Southern polar cap contains mix of water ice and carbon dioxide ice. Subsurface ice detected by radar extends across much of planet, surprisingly close to surface, even at low latitudes. Estimates suggest enough water ice exists to cover entire planet, 35 meters deep if melted. That water awaits future explorers, potential resource for human settlement. Mars once had liquid water flowing across surface. Evidence preserved in ancient rocks tells story of wetter, warmer past. Olympus Mons towers over Martian landscape as largest volcano in entire solar system. Height, 21.9 kilometers above surrounding plains, 2.5 times Mount Everest's 8.8 kilometers. Base diameter, 600 kilometers, approximately the size of Arizona. Summit caldera, 80 kilometers wide, contains multiple collapse craters where magma chamber roof fell inward. This is Shield Volcano, built by countless lava flows over millions of years. Gentle slopes despite enormous height. Standing at base, you wouldn't see summit. Curvature of smaller Mars hiding peak beyond horizon. Largest mountain humans have yet discovered anywhere. Waiting silently in red dust. Valles Marineris stretches 4,000 kilometers across Martian surface. Length would span from New York to Los Angeles if placed on Earth, covering nearly 1/4 of Mars's circumference. Width reaches 200 kilometers in places. Depth plunges 7 kilometers below surrounding terrain. 7 times deeper than Earth's Grand Canyon, which measures 1.8 kilometers deep. This canyon system formed not by river erosion despite the name, but by crustal rifting as Tharsis volcanic plateau uplifted, splitting surface. Standing at rim, opposite wall would be barely visible across immense gulf. Largest canyon system in solar system, dwarfing any terrestrial comparison. Magnificent scar across red world. The Tharsis Plateau rises as massive volcanic province. Elevated 10 kilometers above surrounding plains, this region contains 4 enormous shield volcanoes, including Olympus Mons. Marcia Mons, Pavonis Mons, Ascraeus Mons, align in row like sleeping giants. This bulge in Martian crust resulted from massive volcanic activity over billions of years, lava accumulating, building mountains, reshaping entire hemisphere. Tharsis uplift likely caused Valles Marineris rifting nearby. Evidence suggests volcanism continued until relatively recently in Martian history, perhaps 100 million years ago. These volcanoes may not be completely extinct. Mars may yet hold geological life within. Hellas Planitia forms one of the largest impact craters in solar system. Diameter 2,300 kilometers, depth 7 kilometers below Martian datum, this basin dominates southern hemisphere. Formed approximately 4 billion years ago when asteroids struck Mars. Impact was so violent, it created shock waves that may have triggered volcanic activity on opposite side of planet where Tharsis now stands. Today, Hellas fills with dust, occasionally hosting ice deposits during winter when temperatures plummet. Atmospheric pressure at Hellas basin floor reaches highest levels on Mars due to elevation, still only 1,150 pascals. Ancient scar from solar system's violent youth, preserved perfectly in dry Martian air. Crater remembering. Polar ice caps grow and shrink with Martian seasons, visible through telescopes from Earth. Northern cap, primarily water ice, permanent, covered by seasonal carbon dioxide frost in winter that sublimates in spring. Southern cap contains both water ice and carbon dioxide ice, some permanent carbon dioxide persisting year-round. Caps contain layered deposits, alternating dust and ice layers, recording millions of years of climate history like tree rings. Scientists study these layers to understand Mars's climate cycles, orbital variations, atmospheric evolution. Seasonal changes dramatic enough that early telescopic observers noted polar caps advancing and retreating. Mars shows its seasons to patient watchers, ice dancing between poles and atmosphere with annual rhythm. When Galileo Galilei turned his primitive telescope toward Mars in 1610, he observed phases like Moon and Venus. This proved Mars was world, sphere reflecting sunlight, not mere point of light. But his telescope lacked resolution to reveal surface features. In 1877, during favorable opposition, Italian astronomer Giovanni Schiaparelli mapped linear features he called canali, meaning channels. Term was mistranslated to English as canals, implying artificial construction. This sparked decades of speculation about Martian civilization. American astronomer Percival Lowell built an entire observatory in Arizona, specifically to study these supposed canals, producing detailed maps showing extensive network. Fiction born from optical illusions and wishful thinking. Percival Lowell observed Mars obsessively from 1894 until his death in 1916. He produced intricate maps showing hundreds of straight lines crisscrossing Martian surface. He wrote passionate books arguing these canals were irrigation systems. From his writings, Lowell declared, "Mars Mars orbits the Sun at an average distance of 227.9 million kilometers. That's 1.52 astronomical units. The orbital period lasts 687 Earth days, nearly 2 Earth years. Mars follows an elliptical path, eccentricity 0.0934, causing its distance from the Sun to vary by 20% over the Martian year. A Martian day, called a sol, lasts 24 hours, 39 minutes, and 35 seconds. Remarkably similar to Earth's 24-hour day. The most Earth-like planet in our solar system for day-night cycle timing. This similarity simplifies future human settlement planning. Mars tilts 25.2 degrees on its axis. Earth tilts 23.4 degrees. This creates seasonal variations similar to Earth's. Polar ice caps grow in winter and shrink in summer. Seasonal dust storms sweep across the surface. The Martian year equals 668 sols, or 687 Earth days. Seasons last roughly twice as long as Earth's seasons. Northern spring lasts 194 sols. Southern spring lasts only 142 sols. The orbital eccentricity creates this asymmetry. Mars's atmosphere is 95.32% carbon dioxide, 2.7% nitrogen, 1.6% argon, just 0.13% oxygen. Traces of water vapor and methane drift in the thin air, an atmosphere completely different from Earth's nitrogen-oxygen mixture. The atmospheric pressure averages 600 pascals. That's 0.6% of Earth's sea level pressure, roughly equivalent to pressure at 35 kilometers altitude above Earth. Too thin to breathe, but thick enough to support dust storms and wispy clouds. Temperature on Mars averages -63 degrees Celsius. It ranges from -140 at the winter poles to +20 at the equator during summer days. Extreme variations due to the thin atmosphere's poor heat retention. Mars is colder than Earth despite similar day length. Substantial water ice exists in the polar caps, mainly at the North Pole, covered by seasonal carbon dioxide ice in winter. Subsurface ice detected by radar across much of the planet. Estimated enough water to cover the entire planet 35 meters deep if melted. Mars lost most of its atmosphere billions of years ago, around 4 billion years ago, when the magnetic field collapsed. Solar winds stripped away the atmosphere no longer protected, transforming Mars from potentially warm and wet to cold and dry. During Martian winter, temperatures drop to -125 degrees, cold enough that 25 to 30% of the entire atmosphere freezes. Dry ice forms at the polar caps, then sublimes back to gas during spring, creating seasonal pressure variations that drive wind patterns. Olympus Mons rises 21.9 kilometers above the Martian surface, 2.5 times the height of Mount Everest. The base diameter measures 600 kilometers, approximately the size of Arizona, the largest known volcano in the solar system. The summit caldera stretches 80 kilometers wide. Multiple collapse craters mark the volcanic history. A shield volcano formed by lava flows over millions of years. Gentle slopes despite enormous height, built layer by layer. Valles Marineris stretches 4,000 kilometers in length, nearly 1/4 of Mars's entire circumference. It would span from New York to Los Angeles across the United States. The canyon measures up to 200 kilometers wide and 7 kilometers deep. Seven times deeper than Earth's Grand Canyon. Formed by crustal rifting and erosion over billions of years. Not carved by a river despite the name meaning mariner valleys. A canyon system that dwarfs anything on Earth. The Tharsis Plateau contains 4 massive volcanoes: Olympus Mons, Arsia Mons, Pavonis Mons, and Ascraeus Mons. The region stands elevated 10 kilometers above surrounding plains. A bulge caused by massive volcanic activity over billions of years. Hellas Planitia spans 2,300 kilometers in diameter, a depth of 7 kilometers below the datum, one of the largest impact craters in the solar system, formed by an asteroid impact approximately 4 billion years ago, now filled with dust. The polar caps contain layers revealing climate history. The North Pole is primarily water ice, covered by seasonal carbon dioxide in winter. The South Pole contains a mix of water and carbon dioxide ice. Layered deposits record millions of years of Martian seasons. The surface consists of iron-rich basaltic rock, volcanic in origin, coated with iron oxide dust, giving Mars its red color. Perchlorates discovered in the soil by the Phoenix lander, evidence of ancient clay minerals and sulfates indicating past water interaction. Branching valley networks mark the southern highlands. They resemble terrestrial river systems formed 3.8 to 3.5 billion years ago. Massive outflow channels suggest catastrophic flooding events. Deltas where ancient rivers emptied into lakes or seas. Gale crater contains layered sedimentary rocks. formed in an ancient lake lasting millions of years. Curiosity rover explores these lakebed deposits today. Jezero crater holds river delta deposits where Perseverance now searches. Clay minerals widespread across Mars require prolonged water interaction to form. Phyllosilicates detected from orbit, sulfates suggesting water evaporation. Hematite concretions called blueberries formed in water, found scattered across Meridiani Planum by the Opportunity rover. Evidence suggests Mars once held enough water to cover the entire planet, an ocean 100 to 1,500 meters deep, concentrated in the northern lowlands, approximately 3.8 to 3.0 billion years ago, before atmospheric loss transformed Mars from wet to dry. Galileo Galilei first observed Mars through his telescope in 1610. He noted it showed phases like the Moon and Venus. Unable to resolve surface features with his primitive instrument, yet he established Mars as a world rather than a mere point of light. In 1877, Giovanni Schiaparelli mapped Mars during a favorable opposition. He described linear features as canali, meaning channels. The term was mistranslated to English as canals, sparking decades of speculation about Martian civilization. Percival Lowell built an observatory in Arizona specifically to study Mars. From 1894 to 1916, he produced detailed maps showing an extensive canal network. He argued the canals were an irrigation system built by a dying civilization, later proven to be optical illusions, tricks of the eye. Asaph Hall discovered two small moons orbiting Mars in 1877. Phobos, the inner moon, measures 22.2 kilometers in diameter. Deimos, the outer moon, spans 12.6 kilometers. Both are likely captured asteroids, irregular in shape. In July 1965, Mariner 4 made the first successful flyby of Mars. It returned 21 images showing heavily cratered surface resembling the moon. The dream of canal-building civilization died that day. Mars revealed as a seemingly dead, crater-covered world. Mariners 6 and 7 followed in 1969, returning additional images. They showed cratered terrain and measured surface temperatures of -100 degrees Celsius, detected the thin carbon dioxide atmosphere, reinforced the impression of a moon-like dead world. Mariner 9 arrived in November 1971 during a planet-encircling dust storm. Scientists waited weeks for the storm to clear. When it did, revelation emerged. Olympus Mons, Valles Marineris, ancient valley networks suggesting water erosion. Mars transformed from dead world to geologically complex planet. Not moon-like at all, but a world with an active past. Mariner 9 revealed the true face of Mars, a planet worthy of continued exploration. Viking 1 and 2 became the first successful surface missions in 1976. Viking 1 landed July 20th, the 7th anniversary of Apollo 11. Viking 2 followed on September 3rd. Both returned the first color images from the Martian surface. The images showed a reddish-orange rocky desert under a pink sky. The landers measured atmosphere, analyzed soil, conducted life detection experiments. Results were ambiguous, some tests positive, others negative. Most scientists concluded probably not life, but weird soil chemistry. Carl Sagan offered wisdom about the Viking results. Did we find life on Mars? Probably not. Did we prove life doesn't exist? Definitely not. We tested 2 sites on a planet with surface area equal to Earth's land. Imagine aliens landing in Antarctica and Death Valley, finding no life and concluding Earth is sterile. Mars deserves more thorough examination, Sagan reminded us. 2 landing sites cannot represent an entire world. Mars Pathfinder demonstrated the airbag landing system in July 1997. It deployed Sojourner, the first Mars rover, microwave oven-sized. The rover operated for 85 sols, analyzing rocks, proved that rover mobility was feasible on the Martian surface. In January 2004, Spirit and Opportunity landed on opposite sides of Mars. Designed for 90 sols, they lasted years beyond expectations. Spirit operated 2,208 sols, 6 Earth years. Opportunity operated 5,352 sols, 15 remarkable years. Together, the twin rovers traveled over 50 kilometers. They discovered extensive evidence that ancient Mars was wet. Opportunity found hematite blueberries at Meridiani Planum, layered sedimentary rocks and sulfate minerals, proving the terrain was once soaking wet. Steve Squires, the principal investigator, shared his experience. Every morning for 15 years, I woke up and opportunity was still alive. Still exploring, still sending images from another world. The day we lost contact felt like losing a friend. Curiosity rover landed in August 2012 using an innovative sky crane system. A rocket-powered platform hovered while lowering the rover on cables. Adam Steltzner said the engineering team called it crazy. When touchdown confirmed arrived, he burst into tears. Curiosity explores an ancient lake bed in Gale Crater. It discovered organic molecules in 3 billion-year-old rocks. Not proof of life, but building blocks potentially supporting life, demonstrating that Mars had organic chemistry billions of years ago. Curiosity detected methane varying seasonally across Gale Crater. Sources remain unknown. Could be geological or potentially biological. Perseverance rover deployed in February 2021. The most advanced rover exploring Jezero Crater. Ancient river delta deposits preserved there. Perseverance collects rock samples for future return to Earth. First samples from another planet since Apollo. Perseverance collects Mimi Yong managed the Ingenuity helicopter project. Flying on Mars shouldn't be possible, she said. Atmosphere only 1% Earth's density. Carbon fiber blades spinning 2,400 revolutions per minute, 5 times faster than Earth helicopters. First flight, April 19, 2021. "39 seconds, hovering at 3 meters altitude. we'd just flown a helicopter on another planet. Planned 5 flights, achieved 70. InSight lander deployed a seismometer, detecting hundreds of Mars quakes. Measured Mars's internal structure: crust, mantle, liquid iron core. Looking up at night, Mars appears as distinctive orange-red point, steady, unwavering glow, moving slowly against stellar background. That red point in the sky is a place. Real world with mountains higher than Everest, canyons deeper than the Grand Canyon. Mars has polar ice caps growing and shrinking with seasons. Dust devils swirling across deserts. Ancient river valleys recording when water flowed. Robots explore the surface right now, sending images back after 20-minute light delay. Mars is a place we're actively discovering. Distance from Earth varies from 54.6 to 401 million kilometers. At closest opposition, only 54.6 million away. Close by cosmic standards. Current spacecraft require 7 to 9 months transit, fast by interplanetary standards. Mars is reachable, waiting. Mars has seasons like Earth. Longer seasons, colder seasons, harsher seasons, but seasons nonetheless. Spring, summer, autumn, winter. Ice advances and retreats with the Martian year. Dust storms, seasonal and predictable. atmospheric pressure varying annually. The planet breathes with its annual cycle. Mars lives, changes, evolves, responds to seasons, not frozen but dynamic. Ancient Mars had lakes and rivers. Water flowed across the surface. Rain probably fell from thicker atmosphere. For hundreds of millions of years, early Mars might have been wet, warm and hospitable. Life could have emerged. Katie Stack Morgan studies Perseverance's sample collection. Every rock we select could be studied for decades, answering questions we haven't thought to ask. Your breath now. 4 seconds inhale, 4 seconds exhale. Martian day, 24 hours, 39 minutes. Mars continues its orbit tonight. 687 days around the Sun. Peaceful planetary motion. Dust devils swirl across Martian plains right now. Curiosity watches weather patterns, silent, observation. The red planet's ancient valleys hold secrets. Water flowed there billions of years ago. Perseverance collects samples in Jezero crater. Robotic geologist working patiently, bringing Mars home eventually. Olympus Mons rises 22 kilometers, highest mountain in our solar system, majestic volcanic peak. Seasonal ice advances at the South Pole. Carbon dioxide freezing from thin atmosphere. Valles Marineris stretches 4,000 kilometers. Canyon deeper than any on Earth. Ancient geological wonder. Mars and Earth draw closer during opposition. 54 million kilometers apart, neighboring worlds. appears mysteriously in Martian atmosphere. Scientists searching for the source. Questions remain unanswered. The rover's nuclear battery powers exploration. Years of patient discovery ahead. Time enough. Ancient lake beds preserve sedimentary layers. 3 billion years of history. Martian time recorded. Clay minerals indicate prolonged water presence. Mars was wet for millions of years. Ingenuity's blades spin 2,400 times per minute, flying in 1% atmosphere. Remarkable achievement. The butterscotch sky holds suspended dust, pink and orange at sunset, alien beauty. Sample tubes await future retrieval mission. Mars rocks returning to Earth laboratories. Patient planning. Tharsis Plateau holds 4 massive volcanoes, billions of years of eruptions. Geological history. Your breath matches Martian wind rhythms. Gentle breezes across rust-colored plains. Peaceful synchrony. Rest now while Mars orbits. Exploration continues without you. All is well. The red planet keeps watch. Peaceful companion. Mars waits patiently. Rest deeply now. Mars continues orbiting peacefully. red planet glowing in darkness. Ancient valleys rest under stars. Rovers sleep through Martian night. Dust settles gently. Polar caps gleaming white. Olympus Mons, silent, timeless. Ice crystals forming Mars breathes with seasons. Stars wheel overhead, eternal. Ancient world resting